Pythagoras Theorem. Earlier we learned that we can classify triangles according to their angles. In this ABC triangle, all angles are acute angles. Therefore, we call this triangle as acute angle triangle. In the second one, this angle is 90 degrees. Therefore, PQR triangle we call right angle triangle. In the next triangle, it has obtuse angle. Therefore, LMN triangle we called obtuse angle triangle. In this lesson, we are going to talk about this right angle triangle. Now we are going to identify the sides of a right angle triangle. In a right angle triangle, sides opposite to the right angle, side opposite to the right angle is hypotenuse. This hypotenuse is the longest side of a right angle triangle. Other two sides called sides that include the right angle. Sides that include the right angle. Longest side or the side opposite to the right angle is hypotenuse. Then other two side called sides that include the right angle. In this lesson, we are going to identify relationship between sides of a right angle triangle. A Greek mathematician called Pythagoras introduced this relationship. Now we are going to identify that relationship using a small activity. First, draw a right angle triangle and draw squares on each side of the right angle triangle. Then side length of this square is equal to the side length of a right angle triangle. In this square, side length of this square is equal to the side length of QR. And the blue one, side length of this blue color square is equal to the length of PR. Then this blue color one is on the hypotenuse. From next to, not the square on the hypotenuse, from next two squares, select the largest one. In this largest one, draw diagonals and name the intersector point as O. In this square, draw the diagonals and name the intersector point as O. Then draw parallel line to PR through O. Then draw parallel line to PR through O. Then draw a line parallel to PR. Draw a line parallel to PR. Then rotate this square. Rotate this square and again draw a line parallel to PR through this point O. Then again draw a line parallel to PR through this point O. Then cut through these lines. Then you will get 4 pieces. After you cut it, you will get these 4 pieces. Now I am going to label these pieces as A, B, C D. Okay, now I take the first piece and paste it on the square on the hypotenuse. Then take the next one and paste it here. Now I pasted all the 4 pieces. Then I take the small square and paste it on the remaining part. From that we can understand the area of that blue square is equal to the sum of the areas of these other 2 squares. From this activity we can clearly understand that area of the square on the hypotenuse is equal to the areas of the other 2 squares. Area of the square on this hypotenuse is equal to the sum of the areas of the other 2 squares. Observe the relationship between the sides. The area of the square on PR equal the area of the square on PQ plus the area of the square on QR. Therefore, the area of the squares drawn on the hypotenuse is equal to the sum of the areas of the squares drawn on the remaining 2 sides of a right angled triangle. The area of the square drawn on the hypotenuse is equal to the sum of the areas of the squares drawn on the remaining 2 sides of a right angled triangle. Now we are going to write Pythagoras relation to these 3 triangles. In the first one, sides opposite to the right angle is P. Side opposite to the right angle is P. Therefore, P square. If side length of a square is P, area of that square is P times P. We can write it as P square equal sum of the areas of other 2 squares. Sum of the areas of other 2 square. Then area of the square on this side is A times A square plus area of this side is R times R square. Okay. In the second one, hypotenuse is or side opposite to the right angle is X. Then we can write the relation as X square equal Z square plus Y square. In this ABC triangle, hypotenuse is AC, side opposite to the right angle, then AC square equal AB square plus BC square. Okay, now let's find the value of x using Pythagoras relation. Now hypotenuse other side opposite to the right angle is x. Then when we draw a square here, then this side also x. Then area of this square equal x times x, x square. If we draw a square here, and this four sides are equal, then area equal 4 times 4 equal 4 square. When we draw a square here, area of the square equal 3 times 3, we can write it as 3 square. According to the Pythagoras relation, x square equal 4 square plus 3 square. Then x square equal 4 square equal 16 plus 3 square equal 9. Then x square equal 25. Then x equal square root of 25, x equal 5. Now we are going to apply Pythagoras relation to this triangle to find A. Now hypotenuse, sides opposite to the right angle is 10 centimeters. Then we can write the Pythagoras relation as 10 square equal a square plus 6 square. 10 square, 10 times 10, 100 equal a square plus 6 times 6, 36. Then 100 minus 36 equal a square, 64 equal a square. Then a square equals 64. Then take the square root of both sides. Then a equal 8 centimeters. Find the perimeter of the figure. Now we have to find the perimeter of this ABCD figure. Here AB equals 6 centimeters, BC equal 8 centimeters. We have to find the length of CD and AD. But AD and CD are equal. Then this figure is a combined figure. It has ABC right angle triangle and ACD equilateral triangle. Now let's take this side as A. So ACD is an equilateral triangle. Therefore, all sides we can label as A. Now let's apply Pythagoras relation to ABC triangle. Then A square, side opposite to the right angle hypotenuse, A square equal 6 square plus 8 square. Then A square equal 36 plus 64, A square equal 100. Then take the square root of both sides. A equal 10 centimeters. Then perimeter equal, now A equal 10, perimeter equal 6 plus 8 plus 10 plus 10. 6 plus 8 plus 10 plus 10 equal 34 centimeters.